I'm Mark Sponsler, and welcome to the Stormsurf Video Surf forecast for the week starting Sunday, June 26th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. The Antarctic ice shelf is slowly growing as we get deeper into winter down there, up to about 63 south, and it'll go a little bit further than that over the next month or so, and then we'll be at about peak coldness and ice coverage down there. That limits the area of open, exposed ocean for storms to get traction on the ocean surface. So the storms need to be further north, not over ice. Wind cannot get traction on the water if there's feet of ice on top of it, and no swell can be generated. All right, let's move on. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a push in the jet to the north, and, well, there's a little bit of a push here, but that's about the only spot. What that helps do is create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, get groomed out and eventually turn into swell. Swell and hit your beach turns into surf. So we really have a split jet stream flow. The northern branch up here, the southern branch here and weak, and pushing south. That does the exact opposite. When you have the split jet stream flow, you get high pressure in between the two, and that does nothing for generating meaningful swell, at least not the kind we're looking to reach up into Hawaii and the U.S. West Coast. All right, as we get into Monday, the split pattern, or the ridging pattern, if you will, gets its ridging south, only gets worse. The ice line we know is about 63 south here, and you see the jet pushing right over that. So high pressure everywhere. That's Tuesday. Wednesday, it even gets more pronounced. Thursday, we see a bit of a trough trying to develop this Thursday evening south of New Zealand, but not getting very far north, only to about 60 or so. And then it does get further north up to 50 south on Friday, but super pinched off, probably not capable of supporting gale development. And then we go into Saturday, still kind of the same thing. A trough trying to organize, but there's just not enough wind energy there to really make a good steady push to the north. And then we get 180 hours out. The model's sort of hinting, teasing that maybe something might happen. The southern branch and the northern branch might join together and push north, but the model's been teasing like this for 2 days now, something like that, and we're not real confident that's going to happen. All right, let's go take a look at what effect this will have down at the ocean surface. Here we are, surface level pressure, surface level winds, and as expected, a high pressure system at 1036 millibars is east of New Zealand, ridging south, low pressure way down here, not even very strong, and all over Antarctic ice, no winds and no obvious signs of support for swell development. As we move into Monday, yes, a little gale tries to organize, 35, maybe almost 40 knot winds, but it's right on the ice line here and pretty much tracking right over the ice line and moving due east with all fetch aimed off to the east. You really need fetch aimed up at either Hawaii or the U.S. West Coast to try to generate swell. So really no hope there, and the fetch behind it is all aimed southeast. Then we get into Wednesday. Another gale tries to push under New Zealand. Again, right close to the ice line, not really organized, falling apart, 25 knot winds. You really need 40 plus knot winds to generate any meaningful swell. And as we get into Friday, now here, this is looking a little bit more interesting. A gale, 35, 40, almost some patches of 45 knot winds aimed off to the northeast as we continue into Friday night, but it pretty quickly falls apart. And notice this fetch here pushing due south. That seems to be the dominant energy flow right now. Another gale pushes under New Zealand on Sunday, pretty much meeting the same fate, just all aimed off to the east. A zonal flow is typically what drives it, where the jet isn't pushing north with any velocity, and everything ends up in a swell-wise into Patagonia and maybe up into Peru, but pretty much bypassing Hawaii and the U.S. West Coast. All right, let's go look at the effects of these winds on the ocean surface. Now, it's not all doom and gloom, because we're going to go back in time just a little bit to Sunday, June 19th. That was a week ago. A small gale did develop southeast of New Zealand with 22, 23-foot seas building to, well, right here, 29 feet, the highest seas over this whole domain. So 29 feet right there. And then up into the 33 to 36-foot range on Monday, about 6 days ago, aimed pretty well off to the northeast. And then slowly fading, but with secondary fetch developing, producing 20, 22, 24, maybe 25-foot seas, something like that. And then 27-foot seas aimed off to the northeast over a pretty good duration. So this was what we were talking a week ago. So like 4 days in a row of some sort of seas aimed well off to the northeast. Swell from that system is actually hitting Hawaii as we speak and bound for the U.S. West Coast. And there's some sense that perhaps the size might be a little bit bigger than what some of the models suggest. So it took us a while, but we finally got our JSON3 data overlaid over the wave model. We got that portion of the site back up and running again. And so here we'll just 00Z on the 22nd of June. That was Tuesday night last week. Seas were 26, 27 feet in this area, but notice the satellite made a pass right over there, and those purples, those are 30-foot seas. So the max average measurement, that's 15 readings. Each of these slices are really small, about 32.4 feet, with one reading in there at 35 feet. Now, that doesn't mean this whole area was that big, but it suggests that maybe a decent swath of 29 to 30-foot seas were here versus the 26 or 27-foot indicated. That's good. And then there was another pass right here. And when was this? This was 12 hours later, Wednesday morning. And you see another pass made it over with average seas in about the 28, 29-foot range, with one peak reading to about 33 feet, where the model suggests seas were only 24 or maybe 25 feet. So again, the altimeter suggesting seas were higher than what the model was saying. That gives us hope. But then here we are today. That gale, long gone, nothing happening over the South Pacific. We'll put this in motion, and you can pretty much guess at what's going to develop. Yes, there are 30-foot seas, all aimed off to the east. Probably nothing resulting, pushing up into the California swell window. So we get into Thursday and Friday. We know that some sort of activity is forecast under New Zealand, but the reality is seas 22, 23 feet, that isn't going to do anything. That'll get you maybe a 13 or 14 second period, which will be, for the most part, fully decayed by the time it reaches Hawaii and the U.S. West Coast. Tahiti will get swell from it, of course. And then another potential system pushing under New Zealand on Sunday with 28 or 29-foot seas, so maybe some background swell. I mean, that's 6,000 plus miles to Southern California. It should be pretty well decayed and pretty sporadic by the time it reaches there, but at this point, any swell is worth making note of. All right, Barber's Point buoy. We said swell was just starting to hit the south shore of the Hawaiian Islands and better than expected. Here we go. Here's the spectral data. You see peaks at 18 second at 1.9 feet, another one at 2.3 feet. This is just the most recent run of the model. And, you can actually put this into motion if you want to look at it on the site. But it gives you a sense of where the energy is focused. And if you add, it's not really adds, but if you integrate all the heights under this curve, you get a, here we go, primary swell height, 3.3 feet at 17.1 seconds, and that's right about there. That looks like about 17.1 seconds. And 3.3 feet, calculated out, that means surf from primary swell, 5.6 feet. Now, this is one reading every half hour, so literally that could be a single set that's 5.6 feet, and you can theoretically double this on the south shore of the Hawaiian Islands at top spots, but I doubt there's any 10-foot faces, but maybe 7 or 8 feet, so maybe a 50% addition on there due to bathymetric enhancement. So certainly swell is hitting, and you can go down here. We'll scroll down to the bottom real quick, center this up, You can just see how the swell has been building since, well, 12Z, that would be 5, that'd be about 2 or 3 a.m. Hawaiian time when the swell started hitting. And it's been steadily building through the day. Peak reading right now, that's primary swell. Then secondary swell, this is from previous energy that pushed under New Zealand, fading out. So, swell is pushing into Hawaii and bound for California. We'll take it. Wind swell forecast. All right, so right now, Hawaii trades are in control. They're actually stronger than this suggests. I mean, it's full on whitecaps off the South Shore right now. So blowing probably 15 plus knots in this area, though the model only shows 10 knots. Along the California coast, that's about right. Pretty light winds, variable. Take it while you have it. So we get into Monday, pretty much the same deal going on. The tropical storm Celia pushing off. No real swell expected from that. Maybe some 10 or 11 second period energy pushing up into Southern California, but really nothing of any real interest. So we get into Tuesday, north winds, high pressure starts building, north winds start building along the California coast. Yet again, too bad. Water temperatures have at least been tolerable north of Point Conception lately. Trades build for the Hawaiian Islands. So we get into Wednesday. There you go, your typical gradient off of Cape Mendocino, producing some wind swell for North and Central California. Trades pushing into the Hawaiian Islands. Wednesday, you notice Celia completely disappearing. We're into Thursday now. Pretty much the same deal. Building trades for the Hawaiian Islands. Friday, pretty much more of the same. Lighter winds, though, for Northern California. Less wind swell, and trades continue for the Hawaiian Islands. Saturday, new high pressure building north of the island. Trades firmly in control at 20 knots, giving California at least a little bit of a break. And as we get into Sunday, same deal. Actually, a little bit of a low pressure again forecast off the California coast. New tropical system theoretically forecast. We'll see what really happens. Trades continue pretty good for the Hawaiian Islands. And then we are a week out and pretty much more of the same. Wind swell along east-facing shores of the Hawaiian Islands, but decreasing wind swell along the California coast. Quick look at freezing levels on the Pacific Crest Trail where it crosses Tioga Pass Road in Yosemite. A freezing level above 14,000 feet, except for maybe a little spot here on early on June 3rd, night of the 2nd, and then temperatures going significantly higher even after that. So no hope really for freezing temperatures, which is probably a good thing. Snow melt off, making the trail more accessible. All right, what's going on long term with the Madden Jullian Oscillation and the El Nino Southern Oscillation? First up, we look for signs of the active phase of the MJO, the Madden Jullian Oscillation, that periodic weather oscillation that rotates around the planet from west to east on the equator. Two phases, active and the inactive phase. The active phase is the one we want. It acts like low pressure. It feeds energy to the jet stream when it pushes over the West Pacific and dampens trade winds, which in turn can actually take warm water that's in the West Pacific, start pushing it east under the equator in the form of a Kelvin wave. Successive active phases of the MJO can create successive Kelvin waves, which can then take warm water, typically in the West Pacific, and start redistributing it over the off of Ecuador, which in turn can usher in El Nino. And of course, El Nino is great for swell production and water and rain and snow into California. All right, so we're looking at winds. This is data from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the far east Pacific. This is the far west Pacific. That's the equator. All we care about is 5 degrees north and south of the equator. In the east Pacific, we're looking at the arrows. Winds really strong out of the east. The length of the arrow denotes strength. Same thing over the central Pacific. And in the Kelvin wave generation area, the far west Pacific, where when the active phase of the MJO is over here, trade winds can be dampened. Doesn't look like it at this moment. But it's not really the means or the average wind speed. It's the anomalies, differences from normal for this time of year. Winds pick up at certain times of the year. They slow down at certain times of the year. In the far east Pacific, winds are just weakly, we're just looking at the arrow, weakly a little bit stronger out of the east than normal. Same deal over the central Pacific, but in the Kelvin wave generation area, modestly stronger than normal. Probably an indicator of the inactive phase of the MJO. Remember, the active phase of the MJO can actually dampen these winds in this area, if not out and out reverse them, and that's how you get Kelvin waves. So what's the forecast for the next week? We're looking for the east and the west component of the wind only. That's what this is. 850 millibar zonal, east and west component wind anomalies. Differences from normal for this time of year. This is the whole planet on one chart. The blues are easterly anomalies, the yellows westerly anomalies. Westerly anomalies are a reversal of trade winds, so that's what we're looking for, the active phase of the MJO. But let's get ourselves oriented. 180, that's the date line, okay? So that's the West Pacific. The far West Pacific starts about 135 east, so right there. Kelvin wave generation area ends right about there, 170 west. So this is the only box we're really interested in. Dark blues, purples, strong easterly anomalies forecast for the next week, indicative of the inactive phase of the MJO. And you can see the preponderance of easterly anomalies over the past month, but getting much stronger now. This probably will steal energy from the jet stream, just like what we saw in the southern hemisphere, a ridging pattern setting up, probably dampening support for gale development, at least for the next week. Let's keep going. If the MJO is a low pressure system, well, low pressure systems have clouds. So this is a forecast outgoing long wave radiation. Fancy words for cloud cover. If you have clouds, less sunlight can bounce off the ocean and reflect back out off the Earth's surface. If you have high pressure, then you typically have less clouds, more sunlight reflectivity, and you get these yellows. So, and let's orient ourselves. EQ, the equator, South America, Central America, Hawaii, New Guinea, Australia, you get it. Kelvin wave generation area, well, we said the far West Pacific starts about 135 east, so right there, and out to 170 west on the equator. So right in this general area, looks like the inactive phase, the MJO, is in control. That per the statistic model. We got a week. The good news is it's supposed to start breaking up. 2 weeks from now, well, actually 10 days, in the active phase, the MJO starts building, and 2 weeks from now, it starts building yet more. So maybe our season of pain or our week of pain is just a week or so in duration. The dynamic model suggests, well, actually we'll cue them up right here, suggests basically the same thing. But notice the active phase here 2 weeks out versus the active phase projected by the dynamic model, stronger. So hopefully the dynamic model is correct, and we'll have a stronger active phase 2 weeks from now. So basically, you got a week now of once this one swell hits, then there'll be like a week of downtime, good time to go take care of some business, and then maybe another run of swell after that. Next up, phase diagrams, a closer inspection of the same two models, statistic model here, dynamic model here. This is the MJO. These are kind of tricky to read, but the MJO moves from west to east over the Indian Ocean to the maritime continent. That's like Bali. To the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. You can literally see here the MJ. So this is where we started. I guess this was the 17th of May. You could see it doing its traverse around the globe, sort of. And then we get into June, and it sort of noodled around, and here we are on the 25th. The forecast for the next 2 weeks generally has and this is just the active phase. The dots are where the active phase is. If the dots are further away from this circle, they're stronger. So today, the active phase, pretty weak in the West Indian Ocean. Forecast to move to the maritime continent, almost to the West Pacific, depending on which run you look at here. And moderately weak, something like that. The dynamic model showing pretty much the same thing at the maritime continent, week, 2 weeks from now. So some hope, but not super impressive. The upper level model showing potential for precipitation. Again, areas favorable for precipitation have clouds. That's low pressure. That's the active phase of the MJO, and that's the greens. The yellows and oranges, the inactive phase of the MJO, dry air. All right, so this goes out 40 days, each panel 5 days long. South America, Central America, Hawaii, that little dot right there, New Guinea. The equator is 0 degrees. Kelvin wave generation area right there, that's what we're interested in. Inactive phase of the MJO, it looks like over the Pacific today. And this is up pretty high. This is up 200 millibar levels, so 35,000 feet, something like that. It runs about a week ahead of what goes on at the surface. So you see the inactive phase slowly leaching its way out of the Pacific into the Atlantic through July 16th, with the active phase not super strong, but at least it's more coherent than it was a week or so ago, making its way across the Pacific from we'll say early July into the end of into early August, and then another inactive phase forecast after that. Let's keep going. The 1 month CFS model. Again, whole plan on one chart. This is just the east-west component of the winds. The blues, easterly anomalies. The reds and yellows, westerly anomalies. The reds are the active phase. The blues, the inactive phase, roughly speaking. Let's orient ourselves. Date line runs right up the middle. This is past performance here. The dotted contour, these are inactive phases. You can see an inactive phase back in April working its way across the Pacific with the associated easterly anomalies. Then an active phase traversed the Pacific in late May sort of time frame, dragging a little bit of westerly anomalies with it. And then here we are today. Easterly anomalies, inactive. There's no inactive phase indicated, but easterly anomalies in control. Here's hints of the coming inactive phase. Should start in a day or two and make its way across the Pacific through about, July 19th, something like that, with easterly anomalies building pretty strong near the date line, holding the whole way through July. Westerly anomalies hold up over the maritime continent, not making it into the Pacific. And then finally, the 3-month CFS model. Okay, past performance is down here. Date line runs right up the middle. Kelvin wave generation area, West Pacific starts about 135 east, so right there. You can clearly see westerly anomalies trying to sneak into the Kelvin wave generation area as we get into fall. You see strong easterly anomalies, this was back in March, in control of the date line. And now you get the definite sense that they've moved, and starting today, recentered about 150 west. That opens up the West Pacific long term for westerly anomalies to get a little bit better foothold, a lot better than what we've had over the past 2 years, and hopefully bringing in at least a significant cut into La Nina's dominance. But, all right, let's overlay the MJO, see what's going on. All right, here's today, Kelvin wave generation area right there. The dotted contour, inactive phase of the MJO, no surprise, easterly anomalies associated with it. Now here's this next coming active phase of the MJO, sneaking into the Pacific in the mid-July time frame, pretty weak, maybe generating some westerly anomalies, but nothing too impressive, not enough to get a Kelvin wave going. And then another weak inactive phase after that. Then as we get into late July, a significant active phase of the MJO is forecast. And with westerly anomalies making it into the Kelvin wave generation area, about halfway into it. But these easterly anomalies holding from the date line and spots east of there, still, maybe, just maybe, this will help create a Kelvin wave. Let's overlay the low-pass filter. What's going on? All right, the dotted contour here, the high-pressure bias. One could say that as being the, last week we talked about the Walker circulation. That would be the downward shaft of the Walker circulation. Falling air, high pressure, easterly anomalies. This is the low pressure bias. One could say that's the upward traverse of the Walker circulation. We want this to eventually be over the date line with its associated westerly anomalies, but it's not there yet. But this is interesting. 1, 2, building to 3 contour lines right over the core of the maritime continent as we get into fall. All it would take is a little nudge to the east, and we'd be in a lot different place and be in a lot better position for Kelvin wave development if, as we get into October, November, December, which we think is a very real possibility, that this low pressure bias will start shifting. I mean, La Nina's been in place for 2 years, starting to go on a third year now. It should be ready to blow itself out. All right, enough of the MJO. What's going on in the ocean? That's another component. We have the MJO component of El Nino, La Nina, and, helping to nudge it one way or the other. But the ocean down at depth, down 100, 200, 300 meters, helps give us another good clue of what's going on. So, West Pacific here, East Pacific here, data from the TAA buoy array, that series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines on those buoys. The X's are sensors on the anchor line. Take data from the sensors with a model, sort of put it together, and you get a profile of, warm water in the west, cooler water in the east, but not nearly as cool as it was last winter, and that's good. So this is the 29 degree centigrade isotherm, about where it was last week. The 28 degree isotherm, pretty much unchanged. The 26 degree isotherm, also unchanged, and the 24 degree isotherm, unchanged. So warm water in the west, a decent amount of warm water trying to make it to the east. Certainly not the depths of La Nina, but certainly not El Nino either. But it is the anomalies, differences from normal for this time of year, that really matters. Per this model and data, you notice there are lack of data in some places, sensors are out. But where we have data, warm water in the West Pacific clearly pushing to the east, a building ball of warm water in the, we'll say not quite the far East Pacific, but the East Pacific, indicative of a Kelvin wave. We've talked about this. You have trades or anomalies, westerly anomalies blowing here, taking the warm water that's here, pushing it to the east. It makes its way not on the surface, but under the surface of the equator, eventually erupts off of Ecuador, creates a warm pool that gets caught by the trades, and then pushes over the across the equator on the surface. So it's Kelvin waves moving, active phase of the MJO, creating Kelvin waves, taking warm water, transporting it east, having it erupt at the surface, and then backfill across the Pacific Ocean on the equator. That's how you get El Nino. Now there's another model here, probably even a better model, that shows pretty much the same picture, but it shows water temperatures, if anything, maybe a little bit stronger. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 degree anomalies, something like that. 2 to 3 degree anomalies, and another little piece trying to develop out there. And the leading edge of this is a Kelvin wave, making it to about 110 west. Ecuador is over here. The last little bit of cold water from La Nina sitting here, getting squeezed to the surface by this approaching bulldozer of warm water. And you can see it. It actually gets caught by the trades and sort of builds up here. But at some point, all this warm water will fill in here, get caught by the trades, and then start backfilling into here, warming ocean temperatures. And if you get another Kelvin wave behind this, then the atmosphere at some point will pick up on that and start rearranging the jet stream. Sea level anomalies, Jason 3 satellite, strip out all the wave heights, the wind waves, the tide, and what's the sphere of the ocean, the height of it, what is it doing, right? So there's South America, Chile, Peru, Central America, Hawaii right there, the equator right there, dateline right there. Warm or above, not warm temperatures, but sea heights 5, 10 centimeters above normal. That's not very much, but making it the whole way to about 110 west, just what we saw in the other subsurface model. Warm water, so the idea is warm water expands. When it expands, it displaces the ocean surface up a little bit, so one can infer that there is warm water under this whole area. The last little pocket of cool water, here is the Galapagos. This was at minus 10 centimeters last week. It's down to minus 5, suggesting that cool water here is pretty quickly getting pushed to the surface and losing its intensity as the Kelvin wave pushes off to the east. Upper ocean heat anomalies, the upper 300 meters of the ocean surface, you get a sense of how temperatures have been over the past year. West Pacific here, East Pacific here. You can see there was a Kelvin wave last July that made it across the Pacific. As soon as it erupted, boom, cold water blew up again. 1, 2, 3 pulses of cold water, and that really set us up for La Nina last winter. We got a Kelvin wave in December, January, kind of tried to take the edge out, but then here you go, La Nina again. But now we have this, again, Kelvin wave, making it to about 110 west. And you look here versus here, and you get the sense that the whole pile of warm water, you could draw a line right like this, like that. You get the sense that the leading edge of the warm water is making it consistently further across the Pacific at depth, increasing the reservoir of warm water. So as you get even a small Kelvin wave over this area, there's a big supply of warm water. If you get the active phase moving over, you have a big supply of warm water to create a Kelvin wave. Whereas back here, we really didn't have that. The deep warmer waters was very shallow. We're in recharge mode now, and things looking much better. Upper ocean heat anomalies, pretty much telling us the same thing. The volume of warm water between the date line and 100 west on the equator. We were cold in 2021, the fall of 2021. We got a little Kelvin wave thing the early part of this year. But temperatures, you can just see it. That was the peak of La Nina, and we've been on a steady increase from there. I'm sure we are going to dip back down. The models say that, and we'll talk about that in a minute. But it seems like momentum is finally on our side for good. Now we know what the subsurface temperatures look like, and they look warm, and they look like they're getting warmer with a Kelvin wave in flight. But notice on the surface, this is sea surface temperature anomalies, differences from normal for this time of year. And you see the complete opposite picture on the surface. The blues colder than normal temperatures, so South America, Central America, Hawaii, the equator, roughly right in here. Cold water, the typical La Nina, and it's what's on the surface that matters, because that's what's interacting with the atmosphere. So the atmosphere sees colder than normal water. There's less evaporation. That displaces the jet stream and does all sorts of things that generally aren't conducive to storm development over the Pacific Ocean. But we know there is warm water at depth. We know it's on a full march, and that it is at 110 west, so that'd be right here. And pieces of it are actually poking through the surface as the Kelvin wave pushes off to the east, creating some warming on the equator. The last of the cold water right here off Peru. Again, slowly, ever so. One of our followers suggested this is like watching paint dry. It absolutely is. But you can see week to week to week. If you're watching every day, like I do, it's really pretty painful. It's like watching hair grow even. But if you go look once a week, you see, well, temperatures are certainly getting warmer here. In fact, they're getting warmer over this entire area. The density of the cooling is not as strong as it was, suggesting we're moving in the right direction. The trend for the past 7 days, so a little bit of upwelling still, that cold pocket right around, it's at 90, right there. There's the Galapagos right there, getting squeezed to the surface. Little pockets of warming from the Kelvin wave, though the Kelvin wave is very stealthy and very sneaky. It's not erupting too much. You don't really see what's going on. Yes, there's a lot of warming in other places, but it's what happens on the equator is really what dictates everything. Don't ask me why. I don't understand it, but I do know from a lot of experience that water temperature changes on the equator in the Pacific are what change the jet stream over the entire planet, assuming the changes are significant and they are long-lasting. And again, the backed off picture, again, still La Nina signature, cold water in control, little bits of warming here along the equator, looking actually better than we have been for a couple of years, but still not great. You got to get rid of this cold water and get some warming, or at least neutral temperatures over a much larger area here to start really impacting the jet stream, and they need to hold for 3 or 4 months minimum. Temperatures in the Nino 1.2 region, this is that area right there by the Galapagos and Ecuador, still cold, minus 1.63 degrees. You have to be at half a degree below zero or above to just be considered neutral. Neutral is half a degree below to half a degree above. El Nino is above the half degree mark, and it's got to be there for like 5 consecutive months. So clearly a La Nina signature here. But it's this region, the 3.4 area. That's the official El Nino monitoring region. It's on the equator from a point south of California out to about the dateline. Temperatures today, minus 337th of a degree. We're above the La Nina threshold. You have to be there for 5 consecutive months, but we've been there since June 8th or something like that, 7th, and trending at least in the right direction. I think it's the first time they've actually been above the La Nina threshold in at least a year. All right, so what does the atmosphere think is going on? Remember, we talked about it's the interface, but the atmosphere gets its clues from the ocean. If the ocean's warmer, then it changes the jet stream. If it's colder, it changes the jet stream in the opposite direction, at least in terms of surf for Hawaii and California. So we look at pressure in Darwin, Australia, in the Indian Ocean roughly, and Tahiti in the Pacific Ocean, tropical Pacific, and the difference in pressure, not direct difference, you can create an index. The higher the pressure is in Tahiti, the more positive the index gets. Today, 27.55. That's pretty high. And you can see just scanning down here, it has been positive, but for a few negative days, clearly indicative of a La Nina trend still. But this data can be pretty noisy. 30-day average it out, still says we're at plus 15.14 today, and that's, well, we were at plus 17, plus 18, so maybe dipping a little bit, but not significantly. The 90-day average, that's our El Nino La Nina index. Today at plus 17.24, the highest it's been in a year, so it's still going up. This is a lagging indicator, but it indicates today that the atmosphere clearly thinks that we are in La Nina, and if anything, probably not getting any worse, but we're at its peak right now. The suspicion is at some point, especially when that Kelvin wave starts erupting, that'll start increasing evaporation on the equator, and that'll start driving some of these numbers down. But it might be a little bit till that happens. The 30-day moving SOI graphed out so you can just sort of see 0 is neutral. When you're down in negative numbers, that's El Nino. January 2020 and April, that's the last time we were in anything that resembled even neutral. We've been up in La Nina territory, well positive January 2021, and then we're still, according to this, we're falling off our peak. The other index we just saw suggests we're still hovering somewhere around 15, something like that. So we're still near the peak of our second year of La Nina. Now the question is, what's going to happen beyond? Raw data from the CFS model, forecast temperatures for the Nino 3.4 region, the official El Nino monitoring region on the equator, south of California out to about the dateline. Temperatures today, according to this, building to, well, says about 0.65 a degree. We know we're already warmer than that, though this is kind of an averaged out thing. And temperatures to hold into mid-July, and then start dropping. We fall back into La Nina in the October-November time frame. But after that, temperatures theoretically warming up. We suspect La Nina has pretty much tapped out. Warm water trying to build in the West Pacific. The Walker circulation trying to shift off to the east. And this clearly suggests that is what is going to happen as we get into, we'll say, early winter. That said, it'll still take a month or two for the jet stream to pick up on it. But this is the raw data. They have a PDF corrected version, which shows temperatures today, well, where are we? Somewhere around here. Yeah, still about 0.55 a degree below normal. That's probably about right for the model. Peaking at about a half a degree, right at the La Nina threshold, then falling back down to about 3/4 of a degree below normal in October. Well, this is really September, October, November, and then on an upward trend from there. The CPC, what do you want to call it, consensus model, every model known to man that's used for monitoring El Nino and La Nina, all represented here. 0, there's the line right there. The La Nina threshold right there. Let's see, that's the statistic model average. That's the consolidated, that's the dynamic model average, and that's pretty much showing us, let's see, peaking, dropping down somewhere right around, well, they're saying 1 degree as we get into October and November, and then heading up as we get into January and February, only to about maybe a half a degree below normal. So the CFS model, a little bit more positive, if you will. And you can look at the actual numbers, 0.6 of a degree below normal right now. That's June, July, August, September, October, November, December. Now this, if you look at the raw numbers, it says, well, basically we're going to sit about where we are now for the next 1, 2, 3, 4, 5, 6 months, something like that. Then as we get into, this is December, in January and February, then we're going to be tracking right about normal. This looks closer to what the CFS model was saying right there. So the problem is we're going to warm a little bit this summer. Fall, typically, you get this little surge. It can be either a La Nina surge or an El Nino surge. It's looking like a La Nina surge. And then as we get right into about the start of winter, then things start moving in the right direction. So the good news is swell is hitting right now in Hawaii and bound for the U.S. West Coast, and a little bit bigger than forecast. The models kind of undercalled it, at least according to the altimetry data. That's good news. But beyond that, nothing really forecast on the chart, so you better make the most of it. We actually had good run of swell the past couple of days in California and a couple of days before that in Hawaii. So back-to-back swells. After that, things going to settle down. The inactive phase of the MJO takes over for 2 weeks, so good time to go take care of chores. The active phase is forecast beyond that, and then we'll probably get a good push of late season summer swell. Make the most of it while you can. Looking beyond that into fall, La Nina trying to get reestablished. Isn't going to make it. We'll see how well the models do. Just the amount of warm water pushing off to the east kind of makes one guess, and I don't even want to say it, don't want to jinx it, but kind of makes one sense that maybe what nature's going to do and what the models think are going to be two different things, and that maybe La Nina will fade out a little bit earlier than forecast, but we'll stick to what the models are saying right now. Right now, fall, probably not going to be great, but as we get into winter, especially as we get into later January, early February, there probably will be a marked sense that something is changing. The storm track will improve. There'll be more surf. All of a sudden, the jet stream will start dipping further south into California. There'll be rain and there'll be snow in the latter part of winter. Still, we'll probably eke out a quote-unquote normal winter year at best. You know, I'll say 85 to 90% of normal precipitation, and it'll be late, but we'll take whatever we can get. All right, that's it for this week. If you enjoyed the video, give us a thumbs up. There you go. Comments, questions, please write it down. We'll answer, do our best. If you're thinking it, you know 10 other people are too. And if you haven't subscribed, please subscribe. You get automatic notifications when we post the video. If not, go to stormsurf.com. The link for the video is posted at the top of every page of the website. All the data you saw tonight came from stormsurf.com, with the exception of a few other sites, and we give credits at the end of the video. That's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.